Okay, let's go ahead and get started. So, welcome to this session. This session is going to be on the cloud, but I want to talk about it in terms for ISVs. We'll try and tailor it to that because it'll be each way that we go about using the cloud is a little bit different. So I think it'll be a little bit different in your cases. My name is Jesse Anderson. I am an instructor and curriculum developer with Cloudera. I teach people how to deal with big data. So things that are at the scale of Facebook and Google, very huge amounts of data, processing that and working with it. And oftentimes that's married with the cloud, where we're dealing with large amounts of data right there in the cloud. But for the purposes of ISVs, I think you're going to find a lot of value in being able to start things up and just using what you want and just paying for what you use. I think those are the key things that you'll use with the cloud. So let's talk about what was the cloud. Well, not that long ago, the cloud was just that. It was whatever was beyond the firewall for our intranet. And we really had very low expectations of what was out there. It was more, what's the data out there? Let me look something up if I can find it. Maybe my search engine will work for me, maybe it won't. We had very low expectations of what was out there. But as things have changed, as things have went through a lot of changes in technology-wise, our users are expecting more and more out of us from the cloud. So let's talk about what the cloud is now. Well, users are expecting their devices to sync. They're expecting that whatever they see on their laptop matches the data that they're seeing on their smartphone, and it matches the data that they're seeing on their tablet. They're expecting all of that data to be synchronized seamlessly. And what companies are generally doing for that is they're using the cloud, and they're storing that data up on the cloud. That's one example of what we're thinking. And this, depending on what your product is, this may or may not be what your customers expect, but you still can derive value out of that cloud. But suffice it to say, our customers are expecting more and more from us as developers. They're going to be using multiple devices, and they're going to be expecting that the data as they move around between those devices to be seamless, and those sign-ons to be seamless. So here we start representing things in the cloud. We're storing that data. Now there's a couple different models that are out there. Each one with differing amounts of control, differing amounts of complexity, and how much you're going to have to deal with them to start up. So the first one is Infrastructure as a Service, or IaaS. Now, Infrastructure as a Service is the one that we're going to cover. That's what Amazon Web Services is. That's what Rackspace is. Anytime they're giving you some kind of piece of infrastructure and they're saying, here, install your machine, install your computer. It's up to you to start working with it, to install it, to configure it. But then there's other ones. There's Platform as a Service. This is generally a Salesforce.com, those sorts of things, where they're saying, here's a platform. Here's, another example is Google Apps, where they say, as long as you write your code to whatever API we've given you, you can run your service on there without having to do virtually any configuration. You don't have to install your operating system. That person who's providing your platform is going to handle all that for you. And then we have Software as a Service, or SaaS. That's where somebody is going to give you an API and even less of an API, and you're going to interact with that, usually over XML or JSON, and you're going to put data in and extract data out. You might think of, in very similar, smaller examples, things like Twitter API, Facebook API, those sorts of things, Software as a Service. But as I mentioned, Infrastructure as a Service, that's the one that AWS is giving us. So we're going to focus on that one. So Infrastructure as a Service, you're basically given a virtual machine out there. And it is completely up to you to do any installations that you want to do. So that's installations, configurations. If something breaks, it is up to you to not only fix it, but to monitor it yourself. Where as your system goes down, as your service goes down, you're going to have to monitor that yourself. And it's going to be up to you to figure that out. The most popular, well, Somebody had a comment about the cloud, and it's really that there's only one major player, and Amazon is that major player. You see offerings from various other companies. You'll see offerings from Microsoft with its Azure service. You have Rackspace. You have all sorts of companies offering their similar services. But in reality, the biggest one is Amazon Web Services. And I can say that because I know people in the industry who actually work with and analyze this sort of thing where it is their business. And it's really just Amazon as far as they're concerned. As far as customer demand, it is just Amazon. And Amazon is an interesting thing because out of what they saw as a different business, they said, we're really great at creating infrastructure and these data centers, and they said, let's go sell that. Let's sell that to end customers. And that is Amazon Web Services. It is a great service, it is widely used. You can tell how widely used Amazon Web Services is when there's an outage. So when there's a site that's completely down and it's a well-known site like Pinterest or maybe Netflix, more than likely it's not Netflix that's down, it's more than likely Amazon Web Services that's having a problem. And you can kind of see the large scale companies that actually are. You had other companies like Zynga. Zynga was on Amazon Web Services and they transitioned into their own data center. But it's very, very common for small companies and startups especially, where instead of having to go through the effort of acquiring software and acquiring hardware, which can be costly, especially when you're starting to ramp up, they're using Amazon Web Services right from the get-go. And that was kind of the reason why some of these services, like Zynga, for example, they were that small startup that got big, but they were using Amazon Web Services from the very beginning. It's very, very common as I talk to more and more entrepreneurs and people who are starting out with a small business. They're using Amazon Web Services straight away. And we'll talk more about that value proposition that they're giving you later on. So in a very basic sense, Amazon Web Services, we're talking about what's called their EC2 instances, if you've ever heard that name. EC2 instances is basically a virtual machine that you have running on somebody else's infrastructure. This is just like the virtualization that you might run on your laptop. So let's say we have Gianfranco's laptop here. Well, if I were to run a web server on here, it's not going to work very well for a couple different reasons. So let's talk about why you couldn't do that very well. Well, when he turns off his laptop, or he suspends it, or he moves somewhere else, you're going to lose all of that connectivity. Your customers can now no longer actually work with that service that's running on his laptop. You also have internet connectivity, where he was saying about how his wireless goes out here at the hotel. There's important things that we have to think about once we start putting our stuff in the cloud. And one of the things that Amazon does for us is they're going to give us that virtual machine, but they're also going to handle some of the stuff that's happening behind the scenes. Some of the stuff, things like, well, what happens if that hardware goes down? And redundant internet connections. Some of those things that are incredibly expensive when you're starting out, but since you're dealing with the size and the purchasing power of Amazon along with all of its other customers, they're able to give you that redundant internet connection and that nice rack and nice computers as a result. As a result, much cheaper. So in a very, very basic sense, a virtual machine, and then you're going to load an operating system on there. And that operating system is one of your choosing. You can, one of the most common ones is Linux. You can also do Windows. It's really up to you. You can choose your favorite flavor of Linux. My personal one, I usually use Ubuntu. You can use Red Hat, SUSE. all sorts of different flavors of Linux, and of course there's Windows. So what's generally happening is, here's our data center, here's a bunch of computers up in the cloud. All those computers up in the cloud are all running various things, and those computers can actually interconnect. So if you're creating a service that needs to have several different machines all connecting to each other, as well as connecting to customers, you can do all that, where you don't have to just spin up one instance, you could spin up several instances. And as you're dealing with those several instances, you don't have to, you're no longer limited geographically, where you could actually have an instance here on the West Coast and another instance on the East Coast. And that's generally how people are dealing with some of the disaster recovery or some of the downtimes, is they're going to have a disaster site on one side or the other. This is generally more for enterprise customers where downtime is a problem, but this may be something that you, as an ISV, you can consider which way you want to go. It really comes down to a the amount of money that you want to spend, and then there's the levels that you've set up as the expectations from your customers. If your customer is always expecting to be able to sync in some fashion, then you definitely want to have instances located around the world. And although I talked about the US, they can be physically spun up in various places around the world. So that's every place from the US to Ireland to Brazil to Japan. There's ones in Singapore, Australia, and they're adding more and more data centers. So you can think about that in terms of how you want to locate things. One of the things you can think about doing is, if you have most of your customers in, let's say, the east coast of the US and Australia, well, you can physically locate those EC2 instances much closer to your end customers, and as a result, they'll have better user experience. They'll have faster connections as a result. Those are something to think about. When you deal with an EC2 instance, there's it's not quite going to the store and buying give me a dual core 2.66 gigahertz, so on and so forth. It's a little bit weird. Amazon abstracted out some of that information from you. So what they do is they have instance specifications, and they break those down. So although I don't list the price on this slide, each one of these is in gradually increasing prices, and those prices are per hour. So here we have small. So the small instance gives you 1.7 gigabytes of memory, and then they have these EC2 compute units. EC2 compute units are a little bit weird. Instead of saying you get a 1.66 or 2.2 gigahertz or something like that, what they say is you get the equivalent of, I believe it was a 1.6 Athlon processor per compute unit. So as you say one core, you get one core of a 1.66 from 2008. Very weird.
It is. Let's take the second line, 4 EC2 on 2 cores. Does 2 cores refer to a physical CPU, and the 2 ECUs are virtual machines? What's physical, what's virtual there?
So good question. His question is about 4 EC2 units on 2 cores. So let's break that down. So what you'll get is a total of 4 EC2 units broken across 2 cores. So think of it kind of like hyperthreading, where it's a processor, but you get 2 processors or cores. So you'll get 4 units across 2 cores. And that will be, if you were to do a cat proc CPU on your Linux box, you would see two actual cores for that machine. Does that answer your question?
Yeah, and that's unshared?
That is shared. So that's another important point to make. When you're dealing with EC2, part of the reason why you're getting such cheap usage per hour is you're sharing that physical machine with other people. And there is, you don't have to worry about the security side of that. They're not going to reach across into your instance and pull stuff from you. But you do need to think of that in terms of it is a shared resource and they're not going to over-provision. Part of the reason why people use Amazon Web Services so much is what's called under-provisioning, where let's say I have a box and I run 10 people's instances on it. Well, another company might take that same box and do 20 because they're going to say, over on the average, everybody's not going to be using the CPU as much and I'm going to make more money that way. That's part of the reason, that trade-off of I'm going to pay a little bit more for AWS, but I'm going to be able to get much better performance and more sustainable performance as a result of not being over-provisioned.
Could you define instance a little better? What do you mean by an instance?
And so the question is, what do you mean by what does it mean by an instance? An instance is a single virtual machine. So as you spin up one of these small instances, you have a single virtual machine with the specifications of it has 1 gig of memory, it has 1 CPU core, and it has this I/O performance. Probably at this level, you're not going to have to deal with I/O performance, but that is, if you're dealing with pulling in a lot of data in and out, that's a potential.
But if I had 100 customers using my software in the cloud, that would be 100 instances, or?
No, it would just be like a regular machine that you'd have a regular server. So all 100 of your customers would connect to that same machine and work with that same machine. Does that make sense? And this is different. So we want to separate out infrastructure as a service. They're giving you a virtual machine to start working with. Other services, maybe like Google App Engine and those sorts of things, they may spin up a certain number per connection. Question?
I'm still trying to figure out what 2 cores means. Does the 2 cores mean that that's what the virtual machine sees, or is that what is physically hosting it?
Okay, so the question is, what's the difference between, is the physical machine only have 2 cores, or does it have more than that, and those 2 cores is what the virtual machine sees?
No, not the question. When you ask, is the virtual machine a single core or 2 core inside the virtual machine? That's what it's providing to you. Is that what 4 EC2 on 2 cores mean?
Yes, there are two actual cores that are seen by that virtual machine.
And unspecified is what the physical platform is.
Correct. Yes. So to reiterate his question, what does the physical one look like underneath it? Well, Amazon has never disclosed. They never disclose, one, what their machine specs are, and they've never disclosed how many they have. It's this weird thing that these cloud providers do. They won't tell you how many they have. I never have figured out why. I think it's so that they don't get eco-protesters outside their door. Question?
Let's look at the second line. You are saying in the virtual machine configuration, inside the virtual machine, you will see 2 cores. But what about the compute unit? What's that concept?
So your question is, what is the real-world EC2 EC compute unit? EC2 compute unit?
Yeah. What does the compute unit mean to the virtual machine?
So what does the EC2 compute unit mean to the virtual machine? That's your question? It means that it will have the ability to do 2 times what for this specific one, it would be able to do 2 times the processing that a 2008 Athlon could do. It's a pretty funky definition. It means, in a very general sense, the amount of performance that a particular machine can have. So there's nothing in there that if you were to look at the CPU, if you were to do a cat proc CPU in Linux, you would see, it wouldn't say something about EC2 units. it would just say, this is a processor, and you're going to max out at a certain point as you run that CPU at 100%.
So the number of computer units versus the number of cores, which number corresponds to the actual computing power?
The EC2, so the question is, which one corresponds to the compute power? The compute power is the EC2 compute units, so it's this number. That is the actual processing.
So you don't multiply that by the cores.
No. Question in the back?
Well, you might want to point out what they do when you go beyond the compute unit is they charge you more money. So then you have to do the analysis of going to the next level or not, because it might be cheaper to move
Well,
two cores than one core.
you don't get charged extra for, you just max out the CPU at that point.
No, they're charging. I have several EC2 machines, and what happens is they charge you more money than what the baseline was, because you're using more of your compute units than what was spec'd for the one core.
Okay.
There's a crossover which you should go to two cores, and it may get cheaper for you, but if you just go over the capacity of the one core, you just start charging more money.
Okay, I'll have to check into that. I've ran, so as part of the, I won't show them on these slides, but if you go to my website, I've done some pretty extensive testing where it was running at 100% CPU, and I wasn't charged extra for compute units for those. There was another question?
You said that they're priced by the hour.
Yes.
So is there a bandwidth charge or is there a limit to bandwidth?
So the question is, so the first part of that question is, how are you charged and how is bandwidth charged? So what they did is they say each hour is charged. So you get you get charged a certain amount, usually in the cents for these, of you use that machine for a certain amount of time and you're charged X number of cents. So as you run it longer and longer, you'll just be charged per hour for that. That was leading into that. So the bandwidth part is you'll feel a bit nickeled and dimed, where everything is charged a little bit different, and it's difficult to tell you all the different nuances here, but you are charged bandwidth. So as somebody connects into your server to send something in, you are charged the bandwidth for that, as well as a connection potentially. I'll point out at this point, since we're getting a bunch of billing questions, part of I don't understand why, I never have. Amazon makes it very difficult, or more difficult than it should, to figure out exactly how much something is going to cost. So what they did is you're smiling. It is the thing that they made is on their website. If you do a Google search for EC2 prices or something like that, EC2 cost, what they have is one of their engineers in his spare time wrote a calculator to tell you how much something will cost to give you an estimate. Or you can have it say, I want to do this particular thing. I want to run one server, or I want to run 3 servers, stuff like that. They'll give you some totals on that, but it's not. They didn't do the greatest job with being upfront about how much things cost and helping people understand that. If you want to deal with some of the costs and some of how much you're going to be charged and watching for that, there's a company called Cloudability, cloudability.com. They do AWS cost analysis, and they do have free tiers of that. So at the ISV level, I'd definitely recommend, if you don't have that, what can happen and it happens at my company, we will spin up, we use EC2 instances as part of training. And what can happen is somebody can spin up 100 instances, for example, and then forget to close them. So all that time, those 100 instances were running, you're being charged for that. So if you spun up something to try some tests and forget about it, something like Cloudability will help you remember that and see that your cost has went up. So depending on what level you want, what level of service that you want, what you could do is you could start out with one level above what you might think you need, and then start dropping it lower as you see how much you're actually being how much you're actually being charged, or how much you're actually your customers are being inhibited from what they want to do, or how slow it is. Those sorts of things.
One of the great things is you can just instantly move to a lower or higher than you've got any other.
It's not instant. So his question is, can you move instantly between one of these tiers? The answer is no. You can't just change and press a button and it's immediately a now charged at a different level. Yeah, you'd have to spin up a new instance, but it is, the stuff is still there, yes. And we're going to talk about one of the caveats. There's another weird caveat which we'll talk about later about how to deal with some of those reboots. Okay, so we talked about EC2. That is basically the processing engine. That's the virtual machine. But now let's talk about another piece that's called S3. And S3 gives you the ability to store large amounts of data, and very cheaply, in fact. So I store somewhere around 10, 20 gigs a month on AWS on S3, and I get charged about 26 cents. So I'm not transferring that data, but that's just, they'll charge you a price per gigabyte. I can't remember what the price is off the top of my head, but that's pretty cheap. You could make it even cheaper if you want. They have some basically cold storage, what's called cold storage, and it will have a slower access speed, but you'll get charged less per month. If you're trying to archive something, that's something that you could use. S3 is more for, I'm going to save a large amount of data, but I'm also going to be transferring on it. I'm still going to be working with it. We're going to talk more about it later, but you can actually serve a file directly from S3 to an end customer. You've probably done this before, but haven't realized it, where you can actually have, let's say, your program, your executable program, be up on S3 and be downloaded. A lot of companies are doing that to save money. Here is that caveat. This is an important caveat. If there's one thing you take away from this, or two things. One, you can save some money with the cloud. The other one is the difference between Instant Store and EBS, or Elastic Block Store. Okay, so there was a question about rebooting, and I said, and I'll be there. Well, it depends on what your store type is. So they have two different models, and these are different prices as well. So there is a cost savings to doing one or the other. So what you can do is there's this thing called an instant store. And an instant store, if you shut down your virtual machine, that data on that hard disk is gone. Okay? So what you could do is you have the ability to engineer for that. You can say, I want to always store my durable data in S3, or you could mount an EBS, for example. Okay? So EBS is your durable store. As you shut down, as you do certain things, you can use EBS for that. What I would tell you and highly recommend, as you're starting out with Amazon, just do everything with EBS until you get very, very familiar with what you're doing, very comfortable with what you're doing. You'll save a little, you'll pay a little bit more, but the downside of losing all your data, that I would not want to risk that. Are there any questions between these two? And probably the question that you don't know to ask is, how do you choose between one of them? As you spin up an EC2 instance, it will give you the choice of which image you want to spin up, and at that point you choose between an instant store and an EBS. So cost, if you want to, question?
So do they work the same way? The single difference between them, for the purposes you're talking about, is one has the persistent storage,
Yes.
and the other storage goes away. Another one in terms of performance or functionality and everything.
So his question is about what are some of the other differences other than cost. Instant store is cheaper. EBS is faster but more expensive. Those are the key ones. So if you, you actually get higher performance that way. So as far as cost, if you want to learn about what all these costs are, and as you look at those costs, you'll actually have to look and see several different things. You can go to aws.amazon.com/EC2 to get those. You're going to get what it costs per hour, but remember I was talking about how you may feel nickeled and dimed on some of the things that you'll do, and some of the things, I mean, you're not going to get charged hundreds of dollars, but you'll get 5 cents here and 10 cents and $1 there, that sort of, that level. But you will pay for certain things that you'll think, hey, that's kind of weird. You'll get paid, you'll have to pay on connections. As you pull things in and out of S3, you'll have to pay for that. There are some things to keep in mind there. So as you start to try and figure out what your cost will be, do use that calculator as much as you can and give yourself a buffer. Give yourself a 10% a month buffer if you're worried about that. Questions on pricing? Okay. So let's talk about, now that you know a little bit about the cloud and Amazon Web Services, let's talk about it. So I ran the thought experiment of, so I'm an ISV, how would I go about using the cloud? And what I want to preface that with is, if you are using shared hosting already, that is way cheaper than AWS can be. Mostly because now instead of sharing a virtual machine, having your own virtual machine, you're actually sharing that resource with 100 other people. And that's pretty cheap. For mine, for example, is $100 a year for my shared hosting. If you can get by with shared hosting, you'll more than likely be pretty well off. If you can get by with that, once again. If you can get by with those constraints. But if you can't get by with those constraints, if you're one of those people that needs every ounce of control and you need that root password or you need that administrator password on Windows, then this is for you. This is, I want every configuration, I want to be in charge of all this, I want to deal with all those things. Then you want that level of full control where you can choose that variant of Linux. Question?
It's not a question really. You also talk about the VPS because that's another thing that is also there.
Yeah. So VPS is a virtual private server. Those are becoming more common with cloud with shared hosting companies. It's a way for you to, in many ways, have infrastructure as a service, kind of like what Amazon is doing, except they're going to help you out more. They're going to handhold you more. So that's actually a great theme of, if you don't, that I didn't point out, if you don't have some decent admin skills, whether from a Linux command line or the ability to set up your own Windows, this might not be the way to go either. You may want to stick with that shared hosting solution because somebody else is paid to maintain that for you, and somebody else is going to pick up that email for the support. You're not going to get very good support with Amazon. They basically have a forum, and if you have a problem, you can post on that forum, and people will more than likely give you a respond. But you may not get the answer, and it may not be a person, and whatever changes you're going to have to make, you're going to do those yourself. So I point that out for the non-administrative folks out there. But if you do want that level of full control, so that machine belongs entirely to you. You have the root password. You can install whatever programs you want. You can configure it in any way you want. You can really change it to whatever your whims are. And I point that out because there are certain times when, let's say you have a language or you're more familiar with one technology or another. It's very common that shared hosting companies are basically PHP only. Some of them maybe do some Ruby on Rails. So if you are a C# developer, you may find it more difficult to find shared hosting and be able to have a C# web service. Or you want to use that Java web service, well, guess what? You're more than likely going to have to use AWS for that sort of thing. Does that make sense? Okay. Here's another one, and that's improved speed. So you remember when I talked about shared hosting? And well, shared hosting, you could have that same oversubscription problem, except at a significantly higher level, where at a shared hosting, you're sharing a physical machine with 100, maybe 200 other people. So you and those X number of other people are all fighting for resources on that physical machine. And you can have some resource contention, where if one of those people is very active and you are very active, you may be competing for those same resources, and as a result, have lower performance for your customers, for your end customers. You may see that with slower queries, high spikes in those. Those are things to keep an eye on. What you can do with AWS, since there is a lower subscription level for each of those virtual machines, you can, or those EC2 instances, you could have increased performance. You can say, okay, I no longer want a small instance. I've graduated beyond that. I can go to a faster instance, a medium instance, or a large instance, those sorts of things. It is under your control to be able to say, I want to speed this up. I'm getting feedback from my users that things are slower than I really want them. Another option is to do file serving. So I talked a little bit about this. Straight from S3, what you can do is, without even having to spin up an EC2 instance, you can actually have your customers download files. And what you'll pay on that is you'll pay a couple different ways. You'll pay per connection, you'll pay for the storage, and you'll pay for the bandwidth. But overall, the price comparison is very, very cheap, where you're going to get some pretty decent bang for your buck serving that. So let's say all of your dreams come true and you have millions of people downloading your software. Well, guess what? With a shared hosting platform, they may not be able to handle that, but at the scale that Amazon is at, they're able to handle that, because S3 is, Amazon is handling the scale, and making sure that enough machines are able to serve that data, and they're going to deal with some of the switching for that, or the bandwidth, load leveling, thank you. So that's an important thing to think of as you're working with that. Sometimes you may have your executable up there, so it's not just limited to maybe software products. What you could do is you could put a PDF up there of your user manual. You can have it serve all sorts of things. In order to do this, what you do is you upload the files to S3, and then you mark them with the permissions so that people can access them over the internet. And from there, it's just a URL that you give out. So instead of having a URL that points to your website, www.mydomain.com, it'll be s3.aws.amazon.com, and then some extra parts of that. Another one that you may find helpful is what's called Elasticache. What Amazon does is, you remember I talked about how there's large data centers in Oregon, there's large data centers in Virginia, and there's data centers in Sao Paulo, that sort of thing. Well, one of the things that you might want to do to increase download speeds, let's say for an application update, and you want that to be as fast as possible, Amazon has this thing called Elasticache, where they'll actually load a particular piece of data, and they'll have it loaded on more data centers around the US. So just in the US, for example, they have ones that are located in Chicago, there's one in Texas. What you want to do is physically locate the data as close to your end customers as possible, and that will increase their download speeds as a result. That's one thing to think about as you roll out an update, let's say. A question? Question?
Is this the same as the CloudFront network?
It works with CloudFront, but they have it as a separate project or separate product called Elasticache. CloudFront is a little bit different. I'm trying to remember what the exact difference was. I'll have to look it up. I can't remember off the top of my head.
Because from what I know about Cloudera, it does something like this. Basically, based on the request, it actually goes to the nearest data center and delivers.
Yes, yes. So as the data is actually downloaded, let's say you live in Texas, you are going to download from the data center that is physically located in Texas. Okay? So here's another big thing. You can get this all for free. Let me give you the caveats to this free. So if you want to get more information about this, go to aws.amazon.com/free. This will give you for a year, you get a free basic, not even a trial, I'd say. You get some pretty decent service level. So there was one EC2 instance type that I didn't have up there, and that's called a micro instance. So that micro instance is, if my memory serves, it was 800 gigabytes of RAM, one EC2 compute unit, one core, and it's basically enough power to run a website. Maybe depending on what level of interaction that your customers are having with your website, you might be able to run a little bit more, but what this does is it allows you to dip your foot in the water and see, do I really want to do this? So you'll get some storage in S3 for free. You'll get the EC2 compute units for free, the EC2 instance for free. There's some other ones which we didn't cover that are free, but you can go to that URL and find out exactly what they say they'll give you for free for a year. You get a certain, so the question is, what about bandwidth? You do get a certain amount of bandwidth for free. And everything after that, you do have to pay for it. But it's well worth trying it out just to see, is this going to help me out in some fashion? I can't speak to what everybody's doing for their product is, but it should turn your mind and give you a little bit of room to think about it. For free, I'd say it's an investment in time if you want to try it out. Okay, so if you want to get more information about this, there is much more in depth about performance and that sort of thing. I did a pretty in-depth study of cost and performance analysis. It's up on my website. So that's jesse-anderson.com. If you do a search on my site for AWS, what I did is I took and I ran AWS instances at 100% CPU utilization over 4 to 5 hour periods, and then took and compared the performance of each one of those instances so that you could get a general idea of as you guys found, it's very difficult to kind of understand what an EC2 compute unit is. Well, this tried to help out in helping you understand the relative performance difference between those. Then I broke that down into ROI and cost per unit. You may not need to, as an ISV, get into that level. This was more important for enterprise companies where they're running hundreds, maybe thousands of instances, where you need to have a very specific amount of performance that each one of those is giving you as you try to scale. If you want to follow me on Twitter, I'm at Jesse T. Anderson. I tweet about cloud, big data, those sorts of things. If you want to get more information about the cloud and actually go through this as a full exercise, I'm published on Pragmatic Programmers. It's a screencast that I did that covers AWS in depth. It's everything from expecting you to know nothing to here's how to set up a WordPress instance. Here's how to use Elastic MapReduce. Here's how to calculate your costs. There was all sorts of things. The 6th episode, I cover things like Elasticache and their relational database RDBMS instances. If you're interested in learning more about MapReduce, I'm also published on that with Pragmatic Programmers, where I show how to use MapReduce to process large amounts of data. So with that, I'll open it up to questions.
Can you sort of explain how you tie in, say, your own URL to one of these web servers, given that the web server like comes and goes, so presumably?
Yes. So his question is about how do you tie in your URL, your domain name, to a particular EC2 instance. So what you have to do is you'll have to spin up the EC2 instance, and then you'll have to get another thing which is called a they have a special name for a static IP address, and it's elastic IP address. Thank you. So that elastic IP address is what you'll tie in as your DNS as when you have your DNS entry.
So once you've been allocated that IP address, that stays with you?
Yes, yes, and you actually, and that's one thing you actually pay for. You are given an IP address until you decide that you don't want that IP address anymore. And then that EC2 instance is given that IP address publicly. Any other questions? Other question? Okay. Well, I guess what I'd encourage you to do is, it's free. Try it out. Depending on what you do for your particular software, it may increase your abilities in various ways. The ability to speed up for users, improve that user experience. So think about it in terms of how you can improve the user experience with it.
Yeah, could you say just a few words about MapReduce? Because I think yesterday's section got it wrong and conflated MapReduce with the PageRank algorithm. So what is MapReduce? I heard it a couple of years ago, but I forgot.
So the question is, what is MapReduce? So MapReduce, when I was talking about it yesterday, I was talking about it in terms of PageRank. And what Google uses MapReduce for, and with regards to PageRank, is they use it to create an index of the internet. So they index every word on the internet relative to which page it appears on. MapReduce is a way of processing large amounts of data in a novel way. And what it does is, I use playing cards in that particular screencast to show how it works. What you do is you deal with data coming in, and it goes to a map. So if you're used to functional programming languages, are you? No. Procedural, okay. So, what you'd think of it, the map phase is doing is taking data and making it, sending it out to be processed in some fashion. And then there's a second phase called the reduce phase, which you take that data that's come in and make something usable out of it. In the case of the internet, what it's doing is it's saying these are all the words that are on that page, and then the reduce phase is saying these are all the words that appear for all these URLs. The way I do it with the playing cards is and there's an extended trailer that's on my website if you want to take a look at how it works. What I do with cards is I say, here's a pack of cards. For your map phase, you're going to remove every card that is a face card, and I'm just going to keep the cards with numbers around. For the reduce phase, I'm going to sum them up based on the suit. That's an example of what you can do there. So once again, if you want to go to my site, there's a 10-minute extended trailer where I show that playing card. Any other questions?
You talked about the pricing and how you might feel like you're being nickel and dimed. Is there, you mentioned also talking about how to calculate what your costs will be, but is it hard to keep on top of your costs, considering how dynamic the usage could be?
So his question is it difficult to keep on top of your costs depending on, given that it's dynamic? So it can be. When you're a large organization, then it is very difficult because some people will spin up an instance and they'll let it run for a while. That can be difficult. The other times are generally you spin up something to try and test something out and you forget that it's running. So what I'd recommend is use Cloudability from the get-go, and it's free. They're nice guys as well, and you can monitor your costs that way to make sure that something isn't spun up that you're not used to or that you're not expecting. Part of the UI, the web UI of AWS, it's not great about telling you how much you're spending. So it's difficult to think of how much you're going to spend, but it's also difficult to figure out how much you're spending at a given time, oddly enough. So there are a bunch of services that have sprung up as a result. So Cloudability is the one that I recommend. Okay. Well, question?
Yes. So I'm not sure about it. So this is really actually the first time I heard about EC2, but I've used VPS, so virtual machines, virtual servers, shared server, and I use WordPress and I use plugin for like a optimization plugin, something that works well with Mac CDN. So all my images are stored in CDN, so that's very fast. So I understand it's correct that using S3, I know S3 is CDN, right? So
I'm not familiar enough with CDN, but it sounds like the S3 is the same.
so EC2 is kind of like has like everything. S3 and like a virtual server, like a combined.
So his question is relating to S3, the difference between S3 and EC2. So EC2 is the one that's going to give you your computer. So if you were to think about a physical computer and you were to take out the hard drive, that's kind of what an EC2 instance is. It's all the brains, but none of the storage. So S3 using EBS and instant store gives you the storage at that point.
Okay, so maybe the question is, so with using virtual VPS, virtual server, I can use a control panel, and I can use like a PHP, MyAdmin, or like a database, MySQL, all the tools I can use. The EC2 has kind of similar interface.
Okay, that's a good question. Another differentiation. So his question is, on his shared host or on his VPS, there's a great user interface for it. Allows you to make changes to PHP and changes to this and that easily. And that's one of the things that EC2 does not have. They're going to say, here is your virtual machine. It is now up to you to install and configure that. So in that sense, a VPS is way easier to configure and install. You're trading that for the ability to make a bunch of changes yourself and to administrate yourself. So that is definitely a consideration.
No, with the VPS, you actually have a full machine. You can do what you want with it.
You can, but the difference usually is when you start going out in the weeds with your configurations and start changing it yourself, then their configuration program I found will not reflect that correctly, or they won't support you.
No, you're actually working at the operating system level itself.
Yes, but when you're using that through the actual web interface, and you start to go and make more changes, they may not be supporting the changes that you've made.
I'm not so sure about that because you actually are logging in, getting a Windows prompt, working with Windows logins, depending on what you want.
Yes, I understand that you're working with the operating system with the VPS. I'm saying their web interface may not be showing you all the different changes that you've made. And that's just throughout for other configuration programs, even SWT, SWAT on Linux. You can make a bunch of changes that they don't have in the UI, so they just won't be shown there. All right, well, thank you again.